Hey everyone, in this video we're going to talk about an event that at first glance might seem far removed from our world of smart roads and connected vehicles. The recent air crash in Ahmedabad, where a critical fuel cut-off system was activated during takeoff, resulted in a catastrophic loss of engine power. This incident, regardless of whether it was caused by malicious intent, accidental activation or a technical malfunction, sends a chilling message to all safety critical sectors. It highlights profound vulnerabilities in the design and operation of complex systems, and for us in intelligent transport systems, a sector that increasingly relies on interconnected, automated and safety critical technologies, the lessons from Ahmedabad are not just relevant, they're absolutely imperative. Join us as we explore what the ITS sector can learn from this tragedy and how we can apply these lessons to build a safer, more resilient future. Anyway, I'm Alistair and this is at ITS Now. The recent air crash in Ahmedabad sent a chilling message across all safety critical sectors. A fuel cut-off system was activated during takeoff, leading to a catastrophic loss of engine power. While investigations are still ongoing to determine the precise cause, was it malicious intent, accidental activation, or a technical malfunction? The incident clearly highlights profound vulnerabilities in the design and operation of complex systems. For us in the intelligent transport system sector, these lessons aren't just relevant, they are absolutely imperative. Our world increasingly relies on interconnected, automated and safety critical technologies. ITS encompasses a vast array of systems, from driverless vehicles and smart traffic management to intelligent rail networks and interconnected infrastructure. Each of these components, whether alone or as part of a larger ecosystem, carries inherent risks. A failure, be it human, mechanical or cyber related, can have devastating consequences, much like the Ahmedabad tragedy. This incident compels us to re-evaluate how we approach designing and implementing ITS, with a sharp focus on minimising both the occurrence and magnitude of such safety breaches. One of the immediate takeaways from Ahmedabad is the absolutely critical role of human factors in system safety. Even with highly automated systems, human operators remain the final line of defence, and simultaneously a potential point of failure. The Ahmedabad incident points to a potential design flaw where a critical control could be triggered too easily, whether accidentally or maliciously. In an ITS context, this means we must design interfaces for vehicle controls, traffic management systems and emergency protocols to be intuitive, unambiguous and resistant to accidental inputs. Think about it. Critical controls should be physically segregated and guarded so they can't be confused with routinely used features. Perhaps they need additional safeguards like protective covers, or they might require multiple distinct actions to activate. We also need logical redundancy, demanding confirmation, or a sequence of inputs for safety critical actions to prevent single point failures due to human error. For instance, in a driverless car, a manual override for braking might require a sustained press rather than just a momentary touch. And crucially, when a critical control is activated, the system must provide clear visual and auditory cues. Immediate unmistakable feedback to the operator, flashing lights, distinct alarms or clear on-screen messages ensures they are fully aware of the system state. Regardless of how sophisticated our ITS gets, human operators, be they drivers, traffic controllers or maintenance personnel, need rigorous and ongoing training. This training has to go beyond routine operations, including scenarios involving unexpected system behaviour, degraded modes and emergency procedures. Even though the Ahmedabad flight lasted only about a minute, during that high activity takeoff period, it still underscores the need for simulator-based training. Replicating high-stress, low-frequency events in a controlled environment allows operators to develop crucial muscle memory and decision-making skills under pressure. We also need proactive error detection. Training should emphasize recognizing early warning signs of system anomalies rather than simply reacting to full-blown failures. This means understanding the expected behavior of complex systems and being attuned to any deviations. Finally, clear protocols for anomaly response are vital. Our standard operating procedures, or SOPs, need to be comprehensive, easily accessible, and regularly reviewed, particularly for managing unusual or critical system states.
Remember to hit the subscribe button for ITS now.
Now let's talk about a growing insidious threat, the spectre of malice. The possibility of malicious activation in Ahmedabad highlights the escalating threat of incidents such as cyber attacks against infrastructure. As the technologies managing and operating mobility become ever more interconnected and reliant on data, the potential for attack grows exponentially. Imagine a malicious actor gaining control of a critical system, traffic signals, autonomous vehicle controls, or even public transport scheduling. The consequences could be widespread chaos, severe economic disruption, and, terrifyingly, even loss of life. This is why it's absolutely crucial that ITS systems are built with security by design principles, rather than treating security as an afterthought. This means implementing a multi-layered defense, including firewalls, intrusion detection systems, and robust access controls at every level of the ITS architecture. Furthermore, it's essential to ensure data integrity and authentication, verifying that all data transmitted and received within the ITS ecosystem is authenticated and its integrity is confirmed. This prevents data poisoning or spoofing that could lead to erroneous system decisions. Encrypted communication for all ITS components is also vital, especially for safety critical ones, to prevent eavesdropping and manipulation. Regular vulnerability assessments and penetration testing are necessary to proactively identify and patch security weaknesses before they can be exploited. The ambiguity surrounding the Ahmedabad incident's cause, whether accidental or malicious, also highlights the critical need to address insider threats. This requires implementing strict access control and least privilege principles, limiting access to critical systems and data only to those who absolutely require it for their roles. Behavioral anomaly detection is also key, involving the monitoring of user behavior and system logs for unusual patterns that might indicate malicious activity from within. And of course, background checks and vetting of personnel with access to safety critical ITS infrastructure are indispensable. Regardless of the cause, a critical control failure during a high-stakes operation like takeoff points to the need for ultimate system resilience. In ITS, this translates directly to redundancy and diversity. Just as aircraft have multiple engines and backup systems, ITS must incorporate redundancy for critical functions. This can include hardware redundancy, duplicating critical hardware components so that if one fails, a backup can seamlessly take over. We also need software diversity, implementing different software algorithms or even different programming languages for redundant critical functions to avoid common mode failures. And don't forget geographic redundancy, distributing critical infrastructure across different locations to mitigate the impact of localized disasters or attacks. This also extends to fail-safe and fail operational design. Systems should be designed to either fail safely or fail operationally in the event of a critical failure. This further entails graceful degradation, meaning that rather than a catastrophic shutdown, systems should be designed to degrade gracefully, maintaining essential functions even when some components are compromised. And we need automatic fallbacks, where predefined procedures and automated systems are in place to switch to backup modes or alternative pathways in the event of a primary system failure. There is a strong need for post-incident analysis and continuous improvement. The aviation industry has a strong culture of rigorous accident investigation and lessons learned. The ITS sector must adopt a similar approach. This means mandatory incident reporting, creating a culture where all incidents, near misses and anomalies are reported without fear of blame, fostering a true learning environment. It also requires thorough root cause analysis, going beyond superficial causes to identify the underlying systematic issues that contributed to an incident. And we absolutely need feedback loops, ensuring that lessons learned from incidents are systematically incorporated into future designs, operational procedures and training programs. The Ahmedabad air crash is a stark reminder that even in the most advanced technological domains, the potential for failure, both human and systemic, remains ever present. For our rapidly evolving ITS sector, it serves as a powerful call to action by meticulously integrating human factors, robust cybersecurity, and comprehensive fault-tolerant design principles, and by fostering a culture of continuous learning from all incidents. We can strive to build intelligent transport systems that are not just efficient and convenient, but fundamentally safe and resilient for all. The lives that depend on these systems demand nothing less. With the increasing complexity and functionality of ITS systems, we mustn't become complacent about the requirements for safety, resilience and security of these deployments, and ensure that the design process takes on board lessons learnt from this type of incident. Anyway, we've got some really interesting programs coming up over the next few months, along with some great features in ITS Edge magazine. So make sure you don't miss out by subscribing to our channel at ITS Now. It's free and it really does help us to bring you further videos about ITS. Thank you again to everyone who has already subscribed. Thanks for watching. See you next time.